Hi everyone, my name is Anvita Bansal and we are back with another lecture based on strings. So let's move to the SDE sheet and let me show you the problem. So we will be discussing smallest window in a string containing all the characters of another string. Let me just check if you guys are able to see me. Fine. Okay. So having a look at the problem statement. You are given two strings S and P. Let me explain the problem to you. Find the smallest window in the string S consisting of all the characters including duplicates of the string P. Return -1 in case there are no such window present. Otherwise, in case there are multiple such windows of same length, return the one with the least starting index. So let's understand what they are. Time to practice and TOC is your test case. You can ignore the code right now and let's understand this problem statement. So this problem has been asked in a lot of interviews. It's been asked in, you can check the tags VMware Amazon, I guess. So let's see. You are given two strings. Let me write string S. S is time to T I M E T. Let me just T O P R A C T I C E, and another one is the pattern string that you need to find. So the question says that you need to find the smallest window of string S such that you find all the characters that are present in pattern P. They need not to be continuous, they need not to be in the same order as P contains, they just have to be present in the same quantity. It can be more than that also, but this has to be present exactly as it is present. I think it's the smallest. Let me check if in case there are no such multiple windows of same length, considering all the characters including. Okay, so that's what you need to do. In case they are saying, in case you get more windows of same length, let's say you get window of size 3 from from here to here, which contains all the characters of pattern, and you get another window from here to here, again that is of how many letters? 3 characters. So in that case you should return the first window, the window with the index which is smaller than the other window. Starting index should be less than the other window's starting index. That's pretty obvious. So let's move to the solving part. Let me just clear this. Okay, what can you do in this problem? First, the very brute force approach. You go ahead and check all the substrings of S, match the substrings with P. If it contains this substring or the substring containing this string P, in that you will calculate what is the length of that particular substring. The minimum one you will be returning, but we do not want to indulge in the brute force approach. What better can we do? So in this problem, first you need to understand what all characters does P contain and how many times. So if I draw a hash map for pattern P, let's say this is your P map. Okay, so it contains T exactly once, O exactly once, and C exactly once, right? Then there is another map which I will be drawing, and this map will be containing the letters that I found in S, and I will be comparing it with the P map. So for that, this is the entire thing that you need to understand. How are we iterating over S to find the solution for this problem? That is the entire hunch of this problem. So let's see. Let me take an array and wait. So this is your P map, which looks like this. Let me take this P map here, and let me also take this one here. Okay, fine. I want to find TOC, right? Okay, let's start iterating over it, and then we will discuss what possibly we can do. So let's say I am at 0th index. There are 2 pointers that I'm going to take. One is I, let's say other one is J. So I is also here side by side. I am going to maintain where I and J are at. So initially your I is at 0, or let me take them as left and right because that's what I have used in code, so you can easily map this thing with code also. So left pointer and right pointer. Left initially is at 0, right initially is also at 0. Okay, now you move your left is here, your right is here, you move your right pointer here at the first index, means it is already at this index. You check, you are simultaneously going to create a map for this string which will tell you what all characters it contains and in how many, what is the frequency of that frequency map like we normally draw. So map is empty, t is coming for the first time, you add t to it. Now you will ask if this map if p map also contains this particular character, if that is true, then you will check, and if the count of pmap.get, let me not write the pseudo code, you will get confused because the code is quite big. Pmap.get this particular character, if that is equal to your currently map.get c, that means the frequencies are same, which typically tells me the number of times this particular character c is t right now, the number of times it is present in p, if I am getting exactly that number of times present in my map over this string over s, that means all the t's that are present in pattern have also come up in this particular string s. So I can say that the length of the current length, I am taking my current length, that is telling me the what is the required length that you need to find. The total pattern should be containing 3 characters. So currently I have found 1 character, so let me increment the count of my current length. So this will become 1 currently. Okay, you will understand one by one. Let me just move on it. Why? Because character t is present only once in pmap also, now you have found in map also. So current length is 1 and final length, the total length that you need to find should be equal to 3, which tells you that there are 3 distinct characters that you need to find out in this string. If that particular window contains all these 3 characters with the same amount, with the same frequency, then that can be one of the answers for your window size. Okay, so let's move to the next pointer. So your right is now at another pointer, which is, now your right is at this pointer. Okay, let me just take it as r. This is your right pointer. Now your right comes here. Okay, so what is now, is I present in map? No, it does not contain I, so I will add I and the frequency is 1. Now you ask your p map, do you contain? No, I was not needed, so current length will remain same only. So far I have found only 1 required character which was needed. The character which I need was only 1, so current length is 1. Okay, you move your r to next pointer. Your r is here now, so r at this point in time is at 2. Okay, so this character, is it present in pmap? No, so also simultaneously you must be adding in your this map, so this is 1. Now move your right to this pointer. Your right is at this pointer, right becomes 3. Now you get e is not present in pmap, you don't do anything, you just move ahead and fill up your map. It is 1. Let me just extend this map. Okay, fine. Now you are at this character t, so t is present in p map, that is fine. It is present in my map also. You will simply increment the count of t, but tell me one thing, is this frequency count equal to the count that p map contains? No, so I can say my current length is going to remain same only, because I have found a character which does not change my answer anyway. It is present in the window, we just add it in my window and move ahead. Now I get o. So is o already present in pmap? Yes. First of all, it's not in my map, add it in my map and make its frequency 1. Okay, so now you compare it with pmap. Does pmap contains o? Yes, pmap contains o. How many times? Once, and you have also found it once. So I can say till here I have found 2 characters which I needed to be there as they were present in P. So my current length will become 2 now. Why? Because I have found 2 characters which I needed with the exact frequency that they are present in P map. So when are you incrementing the count? When are you modifying the count of your current length? Only when you find the character that is present in P map with the exact frequency that is needed. That means the exact frequency P map has of that character, that should be the frequency of that character in your current map, which is this. If that is the case, you increment the current length. Okay, so you found O. Now you move at this pointer, you find P. P is not already present, you add P and add 1. P is present in P map? No. So you don't do anything, move ahead. Okay, you come at R. R is already not present, I include R in my map. Ask your P map, it contains? No. So you move to the next pointer A, add it to your map. A is not in P map, don't do anything, move ahead. Now you are at pointer C. So C is not present in your map already, you add 1 and ask P map if it contains it. P map says yes, I have C, and exactly 1 time. So your map will say I also have C only once. So you will increment the count of current length. Why? Because still this, starting from your left index till this right index, this window tells you that this window is the window, one such window which contains all the characters exactly that number of times, that as many times it is present in your pattern string, right? So we can verify also, it can be more than that also, but minimum count of characters is exactly equal to the number of times it is present in given pattern. Okay, so if you check this particular window starting from left index, because I kept my left at 0 and only I was incrementing the count of my right index. So currently my right index is at which pointer? Let me check. 0 1 2 3 4 5 6 7 8 9. So right is currently at 9 and left is at 0. So if I want to calculate what is the length of this window, it will be what? 1 2 3 4 5 6 7 8 9 10. So R minus L plus 1 will be your window size. You can calculate the window the length of that substring like this, and also you can append this string to the some resultant string. But wait, one window I found which contained T also. Exactly how many times? Minimum 1 should be there. More it can be there, but at least one time it should be there. It is there. O is there? Yes, O is also there. C is there? Yes, C is also there. So this window of length 10 can be considered as one of the windows. But is it the answer? We want the window to be minimum size, min size window. So let's explore more options. And how can we explore more options? This is the important part you need to understand. How are we going to explore more options? It is, so far you were moving your right pointer as and when you were finding a match, and as whenever you found your current length exactly equal to the total length, which tells you that it contains all the characters of pattern with the same minimum frequency as it is present in your pattern. So that can be one of your windows. But is it the minimum window I can have? So for that, let's now try to exclude the characters starting from left. So what did I do? I started with including the characters first. I started including, let me write it here only. Okay, so this is like you go ahead and include the characters. When your current length becomes equal to your total length, that means you have found that window. But can it be smaller? To explore more options, what do? You shrink the window size by cutting down the characters starting from left. Start excluding the left characters. Okay, so start reducing them and see if we still get a window which contains all the characters of pattern such that your current length still is equal to total length. Till then you keep cutting down omitting the characters starting from left and increment the count of left pointer. You will be doing L plus plus till the time this condition holds true. Okay, as and when this condition fails, again start with your right pointer, increment the count of right pointer and move towards the characters in the direction of right pointer, right? That's what we are typically doing. I hope you got the gist of this. Okay, so let's see. Now my left was it, I will start deleting them. Let me take a. So currently I am at, my left is at 0. So let's remove this first character. So if I remove this first character from my, first of all I will have to remove this from my map. So if I remove it from my map, it will, 2 will become 1 again, correct? Now do the same thing again. Compare this with the map, p map. Does p map contain t? Yes. How many times? 1. And how many times we have? That is also 1. So basically your current length is not altered. You still have t once present in the window, which is starting from 1th index till rth index. So your, when you also omit that character from your map, you are also incrementing the count of left pointer. So your left currently is at 1. Okay, now we are at 1 position. So let's try to remove this character from our window and see still if current length is equal to total length. So if I remove I now, so i's count, first of all I'll make it 0 in my map. Now I will compare if p map contains I. P map doesn't contain, so i's presence or absence will hardly make any difference. Move your left pointer to next index. Now it is at index 2. Okay, compare this m. M will become first of all 0 because I'm removing it. P map does not contain, so its presence or absence wouldn't matter. Move your left pointer to next index, which is E. E will become 0. E is not present in P map. It will not matter. My current length will still be 3 only. So I am shrinking the window size such that my window still has all the characters of pattern, and I am basically minimizing the size of my window, and I will be keeping a track of it. Now my left is at this index, which is index 0, 1, 2, 3, 4, index 4. Now it is at index 4. So first of all reduce the count of this t, which will become 0 in this case. Ask your p map, it contains t. What is the count? 1. But what is the count of t in your map? 0. Now wait. Your current length will become 2. The reason being, you have reduced that count of that character which was supposed to be present in the window. Because if you see the window, since you are removing this character, so window will be considered from L plus 1, right? If you consider this window, it has O, it has C, but it does not have T. So this tells you that at this position you have played with the, means you have altered the current length, which tells you it does not contain all the characters of pattern. So now what I told you, when that condition comes, that means you have reached the maximum of that minimum window size. Okay, so the minimum window size so far must have been this L. What should it be? R minus L plus 1. And this, in this case, R is at which position? It was already at 9. It is still at 9. L was at which position when we tried to remove T? When we tried to remove T, it was at 0, 1, 2, 3, 4. 9 minus 4 plus 1. That means it is of size 6, right? Which is TOPRAC, from left to right, right? Because as soon as I tried to remove T, I saw that current length became 2, which is not equal to total length. So this tells me the character that I was trying to remove must be included, and that length, whichever, what was the window size, that should be considered as one of the other answers to my minimum window size thing. So far, what is the minimum size window you got? So you started with 10, then you finally found a window size of 6, and that window is what? That window string is TOPRAC, and before that the window with 10 size was TIMETOPRAC, correct? Now you find the smaller one. So this is again your potential answer, but now we got a mismatch. We got a current length less than total length. So let's move again, start playing with your right character. Increment the count of R. You include T, and mind it, we have already removed T. That is why we are at this position now. We are at this position, we have already removed T. Now T was 0, T is at this position, right is at this position. First of all, increment the count of T, compare it with P map. It is equivalent, so increment the count of your current length. It will become 3. Now wait, 3 becomes equal to 3. So this is also one of the potential window size answers that you can include. Now calculate its answer. So the window that we got is from PRACT. Am I right? OPRACT. So next window that we got is next window that we got is again of length 6, and that is OPRACT. Now if you compare these two, both are of same length. So if these are potential answers of length 6, then I will be returning this string as my answer. Okay, fine. Now do one thing, since you got this of equal length, keep incrementing, and since you got of equal length, let's try to omit the characters. You remove O now. If you remove O, you will become your O. Where is your O? O will become 0, and this 0 will be a mismatch. Your current length will become 2. So that will tell you that you should increment the count of R now, right? So your R was at 10, now your R is at this position, and your L is at which position? You try to remove O, so your L is at this position. Now when you incremented the count of R, you are at this index I, and I becomes 1. Does it matter? No, it won't matter. Your current length is still 2. So increment R again. Your R is at this position. You increment the count of C, it becomes 2. Does it matter? No, because C was already 1 that we already have. We already had it, so incrementing its count will not affect our window size, means it's not improving the window size, because it is still short of one character which is supposed to be there in this, because our current length is 2 right now. Now you have E. With E you increment the count of E frequency. E is not present in P map, and the current length is still 2. So current length did not become equal to total length after this. So the potential answers, potential window sizes that we got was 10, 6 and 6. So minimum was 6 only, and out of these two we will be returning this one. So I hope you understood this dry run of this example, and what all things I explained is exactly what we are going to do. In this case, we are using two hash maps, one for storing the characters of pattern, one for storing the characters of your string. So you are using the space complexity equal to n plus m, where n is the length of string, m is the length of this pattern, and then you are doing one iteration over this string and making some decisions. So that is big O of n time complexity. Okay, so this is the efficient way. In the efficient way, this is one approach which we can do to solve it. Okay, so let's move to the problem. Let me see if you guys have any doubts. I don't see. Let me check. Wait, if you still have any doubts. So no doubts, right? Okay, so moving ahead with this solution, I highly encourage you to just understand the explanation part, then go ahead and code yourself. I'm very sure you'll be able to. What all we discussed, that is the exact implementation of what I have done here. So I'll just go through it and tell you. So these are some base cases that we have taken. I don't think so there's need to explain it line by line, but yeah, let me tell you what we are doing. We are using two maps, one for storing the characters of pattern, one for storing the characters of your string. This is string map. Okay, then we are iterating over the pattern, storing its characters in your pattern PAT map. Okay, then we are taking this current length, total length, which I explained you. Total length will be equal to the size of your hash map of the pattern, right? So then you are initializing this resultant length as -1, because you're starting with 0. So when you will add that 0th character, then that is when your resultant will become 0. Sorry, yeah, so result here, this is the string, not the length. You are initializing it with -1. You're storing -1 because they are saying if there is no such window, you will be returning what? Result only, right? So you're returning result, so that is why I initialized with -1. Fine. Then in this resultant length is the one you are taking to calculate the minimum window size. So I initialized it with the maximum value you can. Then these are the left and right pointers. Then you start with iteration over your string, given string S. Okay, at each time you ask what's your character. If your map contains, add it. If it does not, if your map contains, increment the frequency by 1. If it does not contain, make it 0 and add it to the map. Then you ask your pattern, if your pattern map contains that character. It says yes. Then check if patterns character frequency is exactly equal to the frequency you are getting for that character in your map. If that is the case, increment the count of your current length. And if current length becomes equal to total length, then start removing characters from the left index. Okay, first of all, calculate what is the window size, store it in the resultant length, and also store that string that is existing in that window in your result, because you want to return the result string. And then you keep on doing this until till the time your current length is equal to the total length. In this test case it was 3, right? So till the time it remains 3, you start removing the characters from leftmost position and increment the count of left. So that is what we are doing. So current character is s dot caret l. So map dot put to, first of all you will remove that character's frequency, you will reduce the frequency by 1 from the map, which is the map of your string s, right? Then you ask your pattern map PAT if it contains that character. Yes, it does. Then you check if the frequency is not equal to the frequency present in map. That means you need to reduce the count of your current length. And if this is not the case, you simply do L++. That means you again remove one character and move ahead. And when you come out of the loop, you are incrementing the count of R++. So you are coming into this loop only when your current length becomes equal to total length, and you keep on doing this until your current length is less than your total length. Then you again do the same thing, doing R++. And this is the entire flow of this code. There is nothing that you cannot understand if you have understood the explanation part that I did. So that is all about this problem. If you have any doubts, you can ask in the chat. Else we will wrap this up. Okay, so to be honest, if the approach is simple, but that thinking, that thought process of inclusion and exclusion is a bit tricky. That is why it has been categorized as hard problem, because it's not so intuitive to think about how we include or exclude in order to get the minimum window. But once you have seen this and practiced on your own, then obviously you can think of problems like this. And then once you have solved this problem on your own, it doesn't remain hard anymore, to be honest. The code is a bit lengthy because we are doing some things which is taking up these many lines of code, but the logic is not that hefty or lengthy as the code looks like. So let's wrap it up then, and that's all. I hope you got this problem. Then see you all in the next lecture. Thank you everyone. Bye bye.